Hey, this is Mr. Kwame. Yesterday we did solving systems by graphing, and wherever the two lines intersected, that was your solution. Today we're doing two ways that uses algebraic methods. So the first is substitution. We should have all done this before, but here's what happens. So this is all about just figuring out the easiest way to plug one equation into the other. And if you look at it, you see that we have a variable solved for right there. It's y, it's by itself on one side, and we know what y is equal to. It's this chunk. So in substitution, you want to always get one variable by itself. Once you've done that, you look at the other equation, the one you haven't messed with, and yeah, we didn't really mess with the first one, but that's the one we were looking at that had the variable by itself. In the next equation, this guy, there's an x and a y, and we see that the y is right here. The reason I care about that is because we have a y solved for up here, and that's the same y. I mean, this is the same y in the system of equations, the same variable. So if I know that, x plus 3y equals -5, but I also know that y in here is really that same y, and that same y is really this thing. All of those things are the same. Y is equal to y, and the top y is equal to 3x plus 5. So I can simply substitute this thing into that y. And we're going to have to do some computation, but when we substitute that in, we're down to one variable in one equation, which we know how to solve. So I rewrote the equation exactly as it is, the bottom equation, but instead of y, I substituted what y is equal to. Namely, this y is equal to that expression. So this y is equal to that expression too. I just plugged it in. The next few steps are just the regular algebra of simplifying equations. So we'll start by distributing. And we have x plus 9x plus 15 equals -5. We need to combine like terms. So these two guys are like each other. They both have an x. That's a 1x. So now this is 10x plus 15 equals -5. And this is just regular solving equations at this point. And so we'll subtract 15 to each side. To try and get x by itself, we do the addition part first. So you have 10x equals -20. The last step, dividing by 10. So we figured that x is -2. That's part of what we want. And then our last step, I mean, we know a half of the ordered pair, so it's 2 something. Your last step is to just plug your -2 for x back into either a top or bottom equation. You'll get the same answer either way. Plug it in for x and solve for y. So I just wrote the top equation, y equals 3x plus 5, but I know that x is now -2. So it's just about simplifying now. Y is equal to -6 plus 5, or -1. And so that's the solution. We did it algebraically, and to briefly recap, all we did was made sure we got one variable by itself. We substituted its equivalent expression, which was this part, into the same variable, y, into the other equation. We simplified and solved it. And then once we had an answer, we substituted our answer into either equation. I chose the top one to solve for the other variable. So that's substitution. So here's another example, and the first part's going to be different, but the rest is going to be the same. So I'll go faster through the second part, but the first part I got to explain. We want to solve, again, same first step. You want to solve for a variable, get a variable by itself. I see that y doesn't have anything in front of it. I mean, it kind of has a -1, and we're going to have to deal with that, but other than that, it's mostly isolated. So I'm going to get it by itself. I'm going to get 2x out of there. by subtracting a 2x to each side. That's going to turn it into a negative 1y on the left, and then a negative 2x plus 7. And I just like writing the variable first. Your last step is to get the negative 1 outside of the y, or away from the y. So you're dividing everything by a negative 1. That makes it y equals positive 2x minus 7. So this first step, again, it's just like getting it into slope-intercept form. But the reason why I want to do that is because if y is by itself, I know that y is equal to this expression. And then in the other equation, there's a y right here. So this y is the same as this y. That means they're both equal to 2x minus 7. I can substitute 2x minus 7 in for this y. What will happen, and the reason why I want to do that is because I'll get one equation, this guy, with only the x variable in it. There won't be any y's, we'll have one variable, and we can solve it like normal. So rewriting it, it would look like 3 times y, but y is really 2x minus 7. And then plus 4x equals 19. The rest is the same as before, it's just we have to distribute, we have to add like terms, and solve for x. So I'm going to go, this is 6x minus 21 plus 4x equals 19. And we need to add like terms, so this is 6x and 4x is 10x minus 21 equals 19. You have a two-step equation here. Get rid of 21 by adding it, adding the opposite. So 10x is equal to 40. Divide by 10, and you get x equals 4. So that was pretty fast, but again, it's the exact same process. You gotta simplify the side, add like terms, and then solve the equation. The last thing we need to do is just, in either equation, we just need to plug in 4. And I actually have this equation right here that I made, and even though that wasn't the original equation, it's the same as this one. I mean, I just moved things around. So I'm going to use that one because it's actually easiest. And go y equals 2 times x, but x is 4, minus 7. Y equals 8 minus 7, which is 1. So if y equals 1, then my ordered pair is 4, 1. So that's a second substitution example.